All right, ladies and gentlemen, welcome back. Let's dive into this last U-substitution integral here. This one would actually be like a harder U-substitution problem in that there's kind of a lot going on and we have to really think intentionally about what our U is. And as we solve for dx, there's kind of some sneaky steps that happen, so you may want to watch this one a few times. So anyways, when we're kind of choosing the U on this one, I'd kind of look inside of the parentheses and kind of look at that innermost parentheses there. And I would say, that you want to choose that square root of x minus 1. And we'll kind of see how that works. And before I integrate it, I'll just call it, x to the 1/2 minus 1. And then our du would be 1/2 x to the negative half dx. And remember, we want that dx by itself. So one thing that I would consider doing right off of a bat is get rid of that 1/2 coefficient. So maybe multiply by 2 on both sides. So the next step, I would have 2 du equals to x to the negative half dx. And one thing I would kind of do when I get dx by itself, I want to divide by the x to the negative half. And I get dx is equal to 2 du over x to the negative 1/2. Now, there's something that we might want to consider doing here to make this a little bit more interesting. Instead of have x to the negative 1/2, I could just call this 2x to the 1/2 du. Now let's see why. Now, if I'm going to, we'll just kind of use the room over here and rewrite this integral problem. So if I'm going to turn this into a new and improved U-substitution integral, I could call this, I got a u squared, and we'll just call this x to the 1/2, and then the dx is equal to 2x to the 1/2 du. And this is all being integrated. Now, there's some really nice things that happen after doing all this work. These x to the 1/2 cancel out, and the 2 can just be moved outside of the integral using the handy property of taking that coefficient type of number and moving it in front of the integral. And I'm left with this nice, simple-looking integral of u squared du. So this is actually a really easy integral now. So let's see, this is going to be 1/3 u cubed plus c. And then I'm just going to call this 2/3 u cubed plus c. And I'm going to just put in what my u was. So that would be square root of x minus 1 cubed plus c. So moral of the story here. Something that looks even like one of these harder U-substitution problems. The work that we did and just getting that dx by itself, using properties of exponents, thinking about what's outside of our u, trying to get stuff to cancel out. And maybe it won't always cancel out, and then if it doesn't cancel out, then there's other tools that you'll have to learn other than U-Substitution in future calculus courses to deal with that. But if we do get stuff canceling out, we can really turn this into a really easy power rule integral problem and just substitute that u back in, the square root of x minus 1, and we get the answer pretty fast. So this is a really good problem to kind of understand the nuances of U-Substitution. The next videos that we're going to look at would look at a case of using trig. And the trig U-Substitutions really aren't too bad, as long as we know, those trig antiderivatives pretty well. Thank you very much, and stay tuned.